Hello, students again. Now we want to do Chapter 3, Section 3, Part 2. We want to talk about reference angles. The first thing we need to know is some definitions and some words. So let's start with defining what it is. Let theta be an angle in standard position. The reference angle, which I'm going to write over here, reference angle, okay? And we're going to try to make this so you can read it. It's angle, and we're going to, so the reference angle, okay, for theta is the acute, and let's highlight that because that's important. Acute. What does acute mean? Well, let's write that down. Acute means less than 90 degrees, right? And we'll try to make this, okay? Try to make this so that you can that less than 90 degrees, right? So just keep that in mind. Angle theta prime formed by the terminal side of theta and the x-axis. So let's highlight that as well. So it is important that you know that it goes to the x-axis. The relationship between theta and theta prime is shown below for non-quadrantal. And that's going to be important. So let's highlight that. Non-quadrantal angles. That means it's not 0, pi over 2, pi, 3 pi over 2, or 2 pi, such that theta has to be between 90 and 360 in degrees and between pi over 2 and 2 pi if it's in radians. Okay? So let's also highlight some things that you're going to need to know. Very important. Quadrant 2. If it falls in quadrant 2, look what happens here, degrees and radians. If it falls, let's change this color to orange. If it's in quadrant 3, it's going to be like this, depending on the angle, whether it's degrees or radians. And last but not least, let's talk about quadrant 4. So if it's in quadrant 4, it's 360 minus theta. And then in degrees and in radians, it's this. Notice quadrant 1 isn't indicated because quadrant 1 is already an acute angle. So it is what it is. So if it's in quadrant 1, you got it made. It's only when it's in quadrant 2, 3, and 4 that you have to apply this. So now let's go in and let's talk about and let's do some examples of reference angles. All right, let's start off with this one. Find the reference angle theta for A. Okay, so we're going to do A over here. Okay, and remember that it is 5 pi over 3. Okay, so we're going to say 5 pi over 3, okay, is equal to what? Well, I like to do this, 1.6 repeating pi, okay, and let's erase a little bit of that so it's not so bad, okay? And the reason I do that is so that I know that it's in which quadrant. Well, quadrant is 0, a half, 1, 1.5, and then 2. So that's between 2 and 3. So that's going to tell me that it is, okay, it is going to be in quadrant, oops, in quadrant, let's go here, Okay, and that's going to be in what quadrant? That's going to be in quadrant 4. Okay, and that's important to know because when it's in quadrant 4, okay, we're going to draw out, okay, and we're going to draw a XY so that we know what the shape looks like. So let's draw it here, okay, and let's draw like, oops, that's too much. Let's go back. Let's fix that, and let's just go a little bit more, okay, like that. And let's just move it, right, so that it looks nicer. And now let's go in and let's draw that, okay? So that angle is going to be what? In quadrant 4, it's going to start here, and it's going to go right about here somewhere. And then let's just draw a nice straight line from here down, okay? So it looks like that, all right? And that's going to be my degrees of, or rather radians, right? So that's going to be 5 pi. Just get this to work. So this is going to be 5 pi over, okay, over 3. And it goes right to here, okay? Well, in order for us to do this correctly, okay, we need to find the angle formed by a perpendicular. So let's extend this and let's change the color so that you see what I'm doing. So we're going to go from there, okay? We're going to go from here straight down, okay? Because that's going to give me, okay, the right triangle, okay? It's going to be right about there, okay? And then I'm going to do like this. Oops, it doesn't want to move. Okay, so let's go here. Okay, and then we're going to do like this. So that's a right triangle. Let's erase it and make it a little neater. All right, there's my right triangle. So what am I looking for? I'm looking for this right in here. Well, what's that in there? Remember that it's in quadrant, right? It's in quadrant 4, okay? And if that's in quadrant 4, and I'm talking in radians, I need the following. Let's change this to red. Okay, we're talking in radians, so we need to do this. So what we have to do to solve this, okay, is we're going to say 2 pi minus 5 pi over 3, and that's going to give me what? Okay, bear with me while I move this down a little bit so that I could write better. So this is going to give me 5 pi. Now remember, this is over 1, all right? So I've got to multiply top and bottom by 3, okay? So that I could have the same denominator, which is 6 pi over 3 minus 5 pi over 3, which equals 2 pi over 3, okay? And that gives me my answer of my reference angle. Okay, let's go to the next part. Okay, the next part is B. Okay, so let's change the color to this one. All right, and I'm going to put part B on this part here. So I'm going to put B over here, right? And B is we're looking for uh, negative 130 degrees. Okay, well, what's the first thing we have to do? We have to draw our XY plane, all right, so that we know where the shape is going to be. Okay, and I'm just going to draw it like that. Okay, okay, and I'm going to draw my angle, okay, and my angle of negative 130. So that means it's going to go like this, and it's going to go here. Okay, remember that this is now going opposite direction. So this is 90, 180, but it's negative. So my angle is going to be there. So let's just draw a line, okay, which gives me that. So my angle is this, okay, and let's make it like that, okay, and that is negative 130. So let's identify that as negative 130 degrees. All right. So what do I need? The first thing I need is to find the coterminal angle. Okay, now before I even do that, what quadrant is that? That is quadrant 3. All right, so that is quadrant 3. So in quadrant 3, okay, I need to first find the coterminal angle, okay, in this case. So, and remember, it has to be positive because it has to be positive and it has to be between 90 and 360. So to do that, I'm going to do 360 minus 130 is equal to 230 degrees. All right? So in order to find the angle that I need, okay, the reference angle, which would be, let's mark it here, which would be this angle, right? Theta, okay? And I would need to draw my right angle here, go straight down like this, all right? And there is my right triangle. This is the angle that I'm looking for, the reference angle, okay? So in order to do that, I have 230, which is my coterminal angle, okay? Coterminal, okay, angle, which I'm going to try to make it so you can read it by doing this, okay, coterminal. I can go and I can fix that by just doing coterminal angle, okay? So that's what I want, all right? So I can bring up a little bit, all right? So that's my coterminal angle. Well, now let's find the reference angle. Well, the reference angle is going to be now from, remember, this is the third quadrant. Well, the third quadrant, I have to subtract this. From this, I have to subtract 180 because I need this right here, right? So in order to do that, I'm going to do 230 minus 180 is equal to, okay, 50 degrees. Okay, and that's going to give me my answer for my reference angle for this part. Okay, so that takes care of reference angles, and reference angles is very important for what we're going to do next. So let's go on to do what we're going to do next. The next thing is that we want to talk about is, okay, and next thing that we want to talk about is evaluating trig functions, okay, and we're going to have okay, to know some things about that. So the first thing that we want to do is let's do some highlighting because we need this, especially for what we're doing now. Let's use green. Okay. First of all, evaluating trig function. Reference angles allow you to evaluate. So you need the reference angles, a trig function. So when you find trig functions, you need the reference angles for any angle theta. The sign, okay, let's highlight that. The sign of the trigonometric function depends on the quadrant in which theta lies, and that's why you have this. Now, I'm going to teach you something very important and hopefully very useful, okay? So let's do this, okay? The first thing I want you to do is I want you to make this note, okay? And we're going to do it in green. I want you to keep the following in mind. I want you to put in quadrant 1, we're going to use A. Then we're going to use S, and we're going to do T, and we're going to do C. Well, what does that mean? All right. A represents, okay, A is equal to all. S represents students, okay. Okay. Let me erase that to make it nice and neater for you. All right. Because we're going to want to, okay, to take, T is take, and C is equal to calculus. All right. Now I know all of you want to take calculus, right? Yeah, I'm sure. Okay. So all students take calculus. That means that all the signs are positive. See? But in the second quadrant, the only one that's positive is sine and the reciprocal, sine and cosine. So we use the S for sine. And then T stands for tangent. The tangent and its reciprocal are positive. And then in quadrant 4, cosine and secant are positive. All students take calculus. All the signs are positive. Sine is positive and its reciprocal. Tangent and its reciprocal is positive. And cosine and its reciprocal is positive. All students take calculus. Very important, okay? So if you know that, and that's easy to remember, but you want to put that in your notes, okay? Now let's see if I could make this nice and neat for you, if it recognizes the words. If not, all students take calculus. Not really. So I'm just going to leave it the way it is, all right? So that it's not so bad. All right, let's go down to this part. We're going to evaluate, first we're going to evaluate the tangent of negative 40 degrees, okay? So let's write that in another color. Let's see, let's take blue this time, all right? And I want to take blue, but I want to take a little bit thicker blue here so that you can actually see it better, all right? So we're looking for the tangent of negative 60. Well, the first thing we want to do is draw out, okay? Okay, so we're going to do this one, and we're going to do A right here, okay? So the first thing that we want to do is draw out our angle, all right? So let's draw out the angle like that, all right? And let's go in and do this. Now it's negative 240. Well, that means it's going to go 90, 180, 240. So it's going to go this way because I'm going negative, right? And then I'm going to draw this line like this. Okay, don't worry about that. It has to be accurate. All right. So then I have this. So that my angle is this, and that is negative 240 degrees. Okay. Well, what's the first thing I need? The first thing I need is the coterminal. The coterminal angle is how we draw angle. Okay. Well, to do that, okay, I'm going to bring this down. Okay. The first thing I need for this is to do the coterminal angle. Okay. Remember, coterminal, plus or minus 2 pi or plus or minus 360. So I'm going to do, I want the positive one. So I'm going to do 360 minus 240. And that equals 120 degrees. Okay. So that's my coterminal angle. I still need my reference angle. Well, what is my reference angle? Okay, my reference angle, which I'm going to abbreviate, is going to be 180 minus 120, which equals 60 degrees. Okay, and I need more space. All right, so that gives me 60 degrees. Well, do you remember the 30-60 right triangle? So let's change colors again. Let's use black this time because I want you to keep that in mind. And let's draw a right triangle. The easiest way of doing that is draw this, okay? And then draw again. And then I'm going to draw another one, okay? And I'm going to draw a line like this. Then I'm going to try another line, and I'm going to go straight down like that, okay? And let's erase it. Erase a little bit of it, okay? And let's draw the right angle there, okay? And remember, what do we have? Okay, well, let's say this is 30. Let's say this is 60. Okay, and you should know that in a 30-60 right triangle, across the 30 is 1, the hypotenuse is 2, and the other side is the square root of 3. So I want, in order for this to be true, I need to look. Now, what quadrant are we talking about here? Okay, well, we're talking about quadrant 2. So let's mark that. Quadrant 2. Well, quadrant 2, okay, if I go up here, okay, if I go to quadrant 2 and we're looking for the tangent, the only one that's positive is sine, which means that my answer here has to be negative. So my answer is going to be negative the tangent of 60 degrees, which will give me the correct answer for the tangent of negative 240 because I need to use the reference angle. Well, the tangent is opposite over hypotenuse, but it has to be negative. So it's negative square root of 3 over 1, which equals the negative the square root of 3. Okay, and there you go with part A. Okay, all right, for part B, let's change the colors again, and let's use, what color should I use for green? Let's see. So I should use, let's try, let's try blue. Let's try like an orange. Let's try this one. All right. So let's do B over here. All right. To do B, now we're talking in radians. Well, 17 pi over 6 is equal to what? It is 2.83 repeating pi. Now I do that because I want to be able to determine easily how far or how great it is. Well, this is greater than, okay, it is greater than 2 pi, which means I'm going to go around the circle more than once, right? So we're going to have to draw out our picture here, and let's go in and draw a XY plane. So I'm going to draw an XY plane like this, a little bit bigger. All right. So then we go back here and we're going to draw it. Well, in order to do that, it's going to go over once and then it's going to go 0.83 more. Well, this is a half and this is 1, so it's going to be in here. So it's going to go all the way around and then it's going to go right somewhere in here. And let's draw a line for that. So this is going to be like something like that. All right. So there is my angle. My angle is right here. Okay. And it is also in the positive direction. So I'm going correctly. Remember, that is 17 pi over 6. Okay. So what I need now is the reference angle. Okay, and what quadrant is that, by the way? So I'm going to put it right here. Quadrant what? Quadrant 2, right? So I want to make sure that I make that because that's going to tell me the sign. Now, all students take calculus. The cosecant is the reciprocal of sine. All students take calculus. The sine and cosecant are positive. So my answer is going to be positive. So I'm going to write that so I can remember to do that. Okay. So since the sine is positive and the cosecant is positive, I'm going to write it over here. Sine and cosecant is positive. Now I can go ahead and first find first I have to find the coterminal angle because it's so far. So to do the coterminal angle, which I'm going to write over here, coterminal angle, okay, is going to be what? Well, remember, that's over 2 pi. So I have to subtract 2 pi. To make it positive, I'm not going to subtract from 2 pi. I'm going to subtract 2 pi from that. But it's in radians, so I'm going to do 17 pi over 6 minus 2 pi, okay, over 1. But I need the least common denominator, so I'm going to multiply by 6 on top and bottom here. And that's going to give me 17 pi over 6 minus 12 pi over 6. Okay? And I need some more space here, so let's move over some. Okay? And that's going to give me equals to what? Well, that's 5 pi over 6. Okay? But that's only my coterminal angle. And I need the reference angle in order to be able to find the answer to my trig function. Okay? Well, what is my reference angle? Let's change the colors again. Let's change it to this one. So now let's do the reference angle. The reference angle, okay, is going to be, remember, we're in the second quadrant. So we've got to subtract from pi over 1 minus 5 pi over 6. And I need to multiply top and bottom by 6. So that gives me 6 pi over 6 minus 5 pi over 6, which gives me just pi over 6, right? Isn't that, and I'm going to write a little note here to help me remember something. Well, if I convert that to degrees, isn't that 30 degrees? All right. Now, I'm only writing it on the side, but I have to stay working in radians. So now I have the triangle already made right here, right, for a 30, 60 right triangle, because I'm looking for the cosecant of pi over 6. So let's write that cosecant of pi over 6, right? Well, the cosecant is the reciprocal of the sine, okay? The reciprocal of the sine. So the sine of 30, we know, is 1 over 2, right? 1 over 2. And we already know it's positive. So I know my answer is going to be positive. Well, the reciprocal of sine of 30 is 2 over 1, right? Which is just 2. So my cosecant of pi over 6 is just 2. Okay? Now that's the end of this section. And I'm going to give you 2 examples to see if you understood what I showed you. Answer those questions and then go on and do the assignment in Google Classroom. Take care. Be safe. Hope I see you soon. Yes, I miss everyone. Bye-bye.